pizza. We are now ready to hear from Noel on coders communication. Noel is a really excellent person in the London Scala community. I'm sure a lot of you have probably heard of him and know him. So he's a fellow organizer of the user group. He ran ScalaBridge for a very long time and helped mentor a lot of new people in Scala. He's written some amazing books. Strongly encourage you to check them out and also to check out his latest book, which he'll have a link to in his slides.
Thanks, Zainab. We'll see if you agree with her assessment when we've been through this talk and I've told you all the ways that I have crashed production. But let's start not with crashing production, but a code base I saw when I joined a project, sat down, cloned the repositories, opened up code, and I see this wonderful line, UUID type string. When you see this code, you just know you're in for a not very fun time. So not what I would consider to be good code. But I think it's kind of interesting to dig into what its problems are. But I'm fundamentally lazy, so I don't want to dig into the problems. I want you to tell me what is wrong with it. So let's have a look at it. What's wrong with this? Type is too wide. Yeah. Okay. So this suggesting it's UUID, but a string can hold a lot of things that are not UUID. So the type is too wide. That's one thing. Anything else that we think is problematic? This code. Oh, okay, one. Yeah.
What is the UUID for?
Okay, well, yeah, that's a good question. What is this UUID? Is it just a UUID we have in our code base for the joy of it, or does it have some other meaning? That is indeed a good point. Right, what version of the UID? What's the representation? Yep, okay. Point. Anything else? Right. Okay, yeah. So I'll just repeat that for people who can hear. Saying it's lying. The UUID is a binary format. Not a string. A string is like a bunch of bytes. Yeah, 16 characters in JVM. The UID is 28 bits, I think. So what's the correspondence here? So indeed, there's a lot that's wrong with this code. So I think when we dig into it, what we have here is a problem about a difference between a representation and meaning. So this is telling us here, the representation is a string, but we have also this name associated with it, and it's telling us that it's a UID. And, these things are problematic. Like we said, the string is too broad. Most strings are not UUID. So there's a whole space of strings that are invalid. That we could. Also, as Zainab pointed out, the UUID doesn't tell us what it actually means. What's the semantic meaning of this? It turns out it's a user ID. This was a system which was basically a single user system. It was the user's ID. There's no way of telling this without tracing the code back. So there's these two layers of meaning, or the kind of two audiences that we're talking to here with this code. All code, in fact. And on the one hand, you have the computer, which cares about the representation of data. How are things stored in memory? How do you actually operate on them? But then you have the developer, who cares about the meaning, which is a different layer, a sort of different level of understanding. So we have these two audiences and these two notions of meaning associated with them. And we need to deal with this somehow in code. And luckily for this particular case, we have a very simple answer, very simple way of dealing with it, which is we could use an opaque type. So we can say opaque type user ID is UUID, and now we can satisfy both audiences. The compiler can tell and look behind the abstraction barrier of the UUID, sorry, the user ID entitled UUID. That tells us the representation, which can be represented compactly, as you pointed out, But from the developer, the semantic meaning is represented clearly in the type, which is there visible in the code, is the user ID. So we can address both axes of communication with an opaque type, solve the problems, make everyone happier. Okay. So this is one of the themes we'll be looking at. There's two different ways. Wind back a bit, actually. First, we'll say code is a form of communication. Code does at least two different things we can think of. We can think of code as controlling the machine, but code is also a medium of communicating. It's a notational mechanism. And they just think of it as a notational system. And controlling the machine is one of the things it does. It also communicates with other things. What does it communicate with? Developers. It communicates with tooling, like the type system and so on. Maybe communicate with your little AI buddies if you use LLMs. So there's these two things that code needs to do, two types of communication. How we run the program, which is like an operational meaning, and then what the program actually means, which you might call a denotational meaning. And if out of interest, that terminology familiar to anyone? I'm curious. Yeah, so we have a few people, like if you're study programming language semantics, you might see operational semantics, denotational semantics. Right. So there's two different ways of looking at it: operational, what a thing does, and denotational, what it means. Two forms of communication we think about. Okay. So this talk is all about how we can communicate more effectively, but I'm looking at mostly how we can communicate to developers effectively. And why is that? Because most of the programs we write are not that performance sensitive. Talking to the computer is not the biggest problem. It's understanding what the code is doing from the developer's point of view. That's the real problem, the real things that slow you down. So what I'm going to do is I'm going to share my shameful, sad stories of crashing production. And at the end of it, if you still give me any credibility at all, you haven't just walked out of the room, we'll talk about how we could address these things by improving communication. We'll see, in fact, that most of these problems can be traced back to poor communication, and they could be addressed quite simply by improving how the code communicates. So let's get going. The sad story number one, the sad story of the email address. So this is the same project that I showed before, the UUID string. I'm going to simplify a lot of details. Some of them are confidential, some of them are just sort of irrelevant. But we basically have a system which is going live as a big release, and we get this problem where users can't log in, and they're using their email address to log in, and it's just not working. Debugging is very painful for many reasons. It's not clear why people cannot log in. All the tests are working, that's fine. There's many layers of system. It's a microservices, big thing. There's PII in here, so there's kind of things you can't log and actually see what's going on in the system. And all these different layers which are having to clear what's going on for a while. And then I click down to extremely embarrassing between email addresses. So what's happening is people are trying to log in their mobile phones. For some reason, people do that rather than using their beautiful computers that they mill out, like spend lots of time with. And typically, phones are capitalizing email, first set of email address. So these email addresses coming in first set are capitalized, and this case sensitive comparison is failing. It's like, you don't have an account, go away. So there we go. So rather than wallowing in shame, I can do anyway. But it's also useful to look at why did this problem persist so long? Why did it take me so long to find it? And I described why the debugging was difficult. But there's more of a sort of mental block which I had, and that comes down to that code had this email type. When I see a type, I think that has semantic meaning attached to it. In particular, if I see something that claims to be an email, I assume it means it's an email which is that it has a bunch of properties that emails have. For example, emails are case insensitive. They have other properties, like they include an @ sign and they have a domain and things like this. So I looked at this email, I got an email. I didn't know where the problem was originating from. I didn't think to look here because we had this nice email type. I think, hey, it's an email. It's going to work like email should work. To the original developer, though, this was just a wrapper. Just the string comes along and claims to be an email, you just shove it in there and you're good to go. So this is communication failure. I had one understanding of what an email meant, type means, and the original author had a different understanding. And we had this disagreement on what types were for, and because that disagreement wasn't explicit, I was looking in the wrong places for a long time. All right. So what does this mean? Well, I think there are two lessons to look at it. Other than maybe I'm a bozo, you might be a lesson to take away. Just like spoken languages, for communication, we need shared understanding, we need agreement on what things mean. And very few teams spend time on this. I know some teams, for example, Etsy actually employs people who work on their ontologies, precisely defining terms. So there are people in Etsy whose job is to be an ontologist. But I think that's very rare. Most companies I've worked on, things are very loosely defined. And therefore, it's very hard to understand what things mean without tracking down the people who originally code. I think that's quite harmful, the example shows. What the other lesson is that you can encode meaning in types. I think that types that encode more meaning, particularly types that encode meaning, are much more useful than types that encode just a representation. So there's a lesson we can take, whether writing code or reviewing code. And what are we trying to communicate with this type? Can we make it more precise? Is this type communicating representation or is it communicating meaning? And if it's communicating representation, can we change it to communicate meaning? Okay. So moving on, I'm now working on a different project. And this one has a homemade ORM. This is already a bit of a side thing, but this is actually kind of okay, but we'll get into it. The way that tables are represented, each table is defined as a class and a companion object. And when you come to do an update, there's methods on these companion objects that have loads of different update methods. Pretty typical, you have these wide tables. So each of these methods has loads of parameters, 30 parameters, some of them. And because of the way the application works, it's kind of like a little spreadsheet in a way. Users are typing little changes in these things, a quote for customers. And as they make changes, those changes are saved directly to the database. So you're often just changing one field at a time or a handful of fields at a time. So they're making the changes directly and you save them, validate it. It's really quite nice. So this has lots of option parameters. Often saying, do I keep the existing value or am I changing it? Because often you're just updating that one parameter. So one field at a time, one column. Okay, so that's all good, except I roll out some changes and then we get this data corruption in production. And we get fields that shouldn't have been changed are just being erased. This is not very good. We don't feel very happy with this code. Luckily, we checked the problem very early to roll back. It wasn't actually a deal, but it's not a great situation to be in. So what is going on? And the problem is these update methods, almost all of the time, option saying keep the current value, but just occasionally, option means no, set the value to null. So we have one type which has two different meanings. There's ambiguity here. So like in spoken language, we have ambiguity. It's a problem. There's a very simple lesson from this, which is first we have types should encode meaning. Types should encode one meaning, not two or three or more. Different types have different meaning. Finding types is cheap. So do it. Particularly with those fake types, it's very cheap. Another way. So that's another way in which we can have poor communication in our code base, but again, fix it very simply. Okay, let's move on to what I think is probably the saddest story of them all. I'm working on the same project and I'm adding a new feature, which basically boils down to adding more conditions onto a query. Additional where clause onto what we're looking at, fixing the data set that we get back. Everything looks good. We have lots of tests, they pass. Staging looks good. We load up staging. They get their salespeople who are working on the product to look over it. They run it. It's all fine. We ship it. And then things just go absolutely crazy. And the way they're going crazy is not like we saw previously, where fields in the same group of being just arrays, but completely unrelated data is getting modified. Right? This is like absolute madness. What is going on here? So again, not a great situation to be in, but the rollback, it wasn't a huge problem. The culprit was this little line of code, which I've sketched out here. So we had query, which had a one where clause, and I said, well, I need to add some more where clauses to this. So we're going to call the same method again. And their little homegrown ORM is implemented so this wasn't like a combinator library where I was adding additional clauses. It was like a little builder style. When it added a where clause, it erased, it dropped the existing one. So what I thought was a query which I narrowed down to a more specific set was actually a query where I had thrown away the initial restriction and just added this clause on. To me, this was absolute madness. The test obviously didn't catch it because who writes tests to make sure that records you're not dealing with haven't changed? So, staging didn't have enough data in it. People weren't looking at it hard enough to see this problem. So it slipped through very easily. But these are all sort of excuses, I think, like what's the underlying problem here? And when I get down to it, to me, it was unidiomatic code. I've used a lot of ORMs. I've never used an ORM that worked in this way. To me, something like the query language is a classic combinator library, algebra, whatever you want to call it. You build these recursive structures, express the query, and then you interpret the query. This one didn't work that way. So I think what we take from this, this is something that could be fixed through types. If you really, really wanted this behavior, you could have a phantom type associated with the fields that have been set, and you could not allow setting a field when the phantom type is whatever value, blah, blah, blah. I mean, I can talk about that later if you're interested in that kind of thing. Particularly complicated, but it is a bit of a diversion. To me, this comes back to cultural expectations. Programming languages have cultures. We have expectations around how things work, like functional code. We expect that things are not mutable, for example. We have expectations, I certainly have expectations around how query languages work. And we work from those expectations. We can't check every line of code. I think it's not feasible. And when code violates those expectations, it can cause surprising bugs. So those are the stories of my mistakes. Now, like, what have I learned from this? So one learning could be, just give it up. Just write books and give talks. So clearly, when it comes to actually programming, I ain't cut out for it. Well, yeah, maybe that's true, but I think there's some other lessons that you can take from it. I think the big thing that got me thinking about these is they're all communication. They're all my expectations of the code not matching, or what I read from the code, what I thought the code was communicating to me was not what the code was saying. And we first example, it didn't cause any problems, but it's just a very annoying code base to work with, which is where the code is talking too much about the representation and not discussing the actual meaning. So it's talking at the wrong level here. In the email type, we had a disagreement about what the meaning of a type is. Is it just a wrapper, we just throw in any kind of stuff, or is it actually finding a restricted set of values which are based on certain invariants, certain properties or methods on them? Case with the options, where we were setting values to null, was where there's ambiguity using one type and multiple meanings. And the case with the where clauses was where code was unidiomatic. The way it conforms my, what I like to think are reasonable expectations of how these types of systems would work. So I see them all as communication failures. What is, I think, important to know about these bugs is they're not the kind of things that people talk about in typical bug hunting war stories. There's no tricky logic here. There's no crazy distributed systems. There's no interaction between timing or things like that. They're all really, really simple things, very basic misunderstandings, and they're fixed with really basic techniques. This is what I think are the basic techniques. And I think this holds for most of our code. Most of our code is not rocket science. It's barely in computer science. It's just very prosaic stuff, doing what are generally quite simple tasks. The things that makes it hard to work with, the fact there's so much of it. And often it's not the best written on the deadline, and it has flaws written by people with different levels of experience. Now, when we look at how developers spend their time, and there are quite a few studies on this, I've looked at some of them. Most of the time spent on program comprehension. I've seen the studies ranging from, say, about 30% to 70% of time spent on program comprehension. Other study I looked at more recent said 58% time. So I think that addressing these type of issues in how we communicate with developers is one of the most impactful things we can do as developers. Stops all these bugs, which I talked about. These are things that showed up in production, they cause problems, and they can all be very, very easily. And this gets to what is like psychopath theory of programmers. One way of programming is by assuming that everyone else is like a psychopath out to get you, and they're going to have done the stupidest things they possibly can to trip you up. That's certainly like one way of approaching it. And I think when I look at this, part of the problem with I was approaching code bases if I had written them. I made these assumptions like about the email type, but maybe that's not the right thing to do. Maybe I should be more skeptical. But the problem with working this way, at least constantly working that way, is incredibly inefficient. If you can't rely on any knowledge, you have to understand the entire code base. You have to like, when I call that ORM where thing, I have to go read the implementation. When I call this update method, which is supposedly like all the other update methods, is the same thing, I have to go and read its implementation to see exactly how it works. That's just incredibly inefficient. We need abstraction barriers. This is why we have abstractions. We don't have to know everything all the time. I also don't want to think about my other fellow programmers as being psychopaths. There's a better thing than that, which is systems. System scale, individual vigilance, just being more careful, doesn't. This is why planes don't fall out of the sky. Don't fall out as often as they used to. The reason is not just because there's somebody shouting at pilots, you have to be really careful. It's because they have systems which prevent bugs. They have things like checklists, and so on. I don't know all the details of aviation safety, but I know that they use lots of checklists that people have to go through every time they take off, every time they do maintenance, and so on. It just prevents problems from coming in. So let's take an example of like a system. So we had the where clause. One way we could test that would we could expand our test harnesses so that we would say, check when we've done something with the database that only the records we expect to be modified in testing were actually modified. Check there were no other modifications. I admit this sounds quite complex to write. I say it, but it's the perfect task to throw to one of your little LLM buddies, if you have LLM buddies, because it's quite easy to specify, but the actual implementation probably requires quite a bit of grubby knowledge about your particular database works, how you can query all the tables in the database and so on, which is perfect for LLM. So they know all that stuff, high level knowledge. Yeah, so that's one way you could do it. The other thing, of course, is that the type system is a system. Who's in the name, right? Yeah, 3 out of the 4 bugs go away with very basic use of the type system. The 4th bug goes away if we get a little bit more complicated, but I just simply wouldn't write it that way. Why would you write this unidiomatic RM? And the other thing about systems is that you don't have to have just one, right? You can have multiple layers. That's a good thing to do. No reason to not solve problems in multiple ways. However, we have to realize that systems don't come from anywhere, don't just spontaneously form. We're not in a Pythagorean world where things spontaneously arise out of the mud. There. No, Aristotle, my bad. So Aristotle had a theory that like frogs and so on just sort of spontaneously spawned out of mud and so forth. Doesn't work. Frogs and flies and not for systems. You have to build them, and Newton tells us an object at rest stays at rest, so we need to keep our systems maintained. So how do you get these things in? Well, wherever there is chaos, there is opportunity. Every time a bug happens, it's a good prompt to ask, how do we stop this from ever happening again? One of the fundamental laws of organizations, they look where the panic is, they look where the chaos is. You can see that happening right now in the European Union. You may have heard about the EU digital sovereignty, right, which is probably good things for all of us, the developers. I think that's something that most people would have said we should, not part of the EU, but the EU should have done for a very long time, but it's only Donald Trump from his power that there's actually the impetus to do it. Thank Donald Trump for one thing at least. So what can we do? Well, code review. I don't find code review very useful for going through logic. I tend not to think of that way, but I think code review is a great time for establishing shared context between the team. And one thing you can look at, and particularly in a code review, is are we naming things usefully? Are we precisely defining what our types mean? Can we actually document this somewhere rather than having an implicit knowledge in people's heads? I think that's a really good use of code review. I think it's very easy to do in code review. I think it's a good time to do it when you have multiple people looking at a bit of code. Type system, of course, communicates to developers and computers. But another thing which I think coming up recently is LLMs. So we get back to this first example I showed of the UUID string. Like, I would definitely want to refactor that. 2 years ago, I probably wouldn't have, because I'm saying it changed. It takes at least several days of work just to get everything compiling again. But now, simple but tedious change like that, throw it at an LLM, it'll be done, and move on. So I think the barriers to making our code bases incrementally better are much lower than they were even a few years ago. All right, so that's all I have to say just about on communication. I hope you can go forth, you learn something from this talk, go forth and make your code communicate a bit better, make your job happier, so make your job easier, make your colleagues happier. Like everybody who I've worked, people want to make their code base better and they want to work with great code bases, but they always feel a bit constrained. Hopefully this gives you a little bit of ideas of what to do and ammunition to work with. Hey, thank you for listening. As Zainab mentioned, I am writing a book. If you want to read it, buy it. It's at functionalprogrammingstrategies.com. I'll find some of these things talked about in there. Thanks again, and take any questions.
So a funny thing is that you mentioned at the end that if you see a bug, then you create a system to make sure that bug never happens again. And I realized that's what I answered to you when you asked how to make things work better with methods. And I think I have this very similar idea with, making bugs for users not happen again. But I guess we need more than just retroactively finding bugs. So what would be the strategies for not maybe doing too much, but just enough? Or like when is, you're too much into types and doing too much, when there's the just enough?
Right. That's a good question. So I think metals is in a difficult situation because you don't control the environment in which you deploy things. So you have a harder time than most of us do. Most people, you work in commercial software on the web, you control the deployment. So your situation is definitely harder. And when you did say, report the bugs to me and I'll try to fix them, I did think of that other scale, that's a problem there. I think part of the system is maybe giving the tools to, in your case, giving the tools to the end users so they can help themselves a bit more than they currently can. Like people like me would try to debug metals more if you knew where to start. Yeah, I've learned a little bit, but I still find it very opaque. Where do you go? Where do you stop? That's an interesting, it's a really interesting question. And I think it comes down to context of the team. So of the things I showed, I don't consider any of them to be difficult. Now, people are not familiar with Scala 3, they might look at opaque types and go, that's something I don't know. Fair enough. Same task, just same type, that type of thing. The only thing that I thought would be somewhat difficult would be the index code data phantom type thing. I don't think it's hugely complicated, but it might not work in all team contexts for people who are quite junior and don't understand that. At the same time, I don't think it's necessary because I don't think the thing should be implemented in that way. But there is always that problem of context. Who are you working with? Can they understand the techniques you're using? I think over time, people learn more. And you can see that in the evolution of Scala conferences, if you've been there for a while. The talks that were 10 years ago are not the talks we have now because that's considered baseline knowledge for a lot of people, like what is a monad and so on. So we do learn more over time, and we have to keep recalibrating what we've learned so that the techniques we can use become more and more advanced. Beyond that, the best you can do is have a culture of learning. Try to teach people. If we adopt the approach, like I'm advocating for here, that the code base is something that we all share and nurture and grow, rather than the code base is something that we occasionally step into, make a change, and then leave, then I think that culture is much easier to work with. If we're looking at continuing improving the code base, then we all invested in the improvements, and we can introduce new techniques. So I hope that gives some ideas of how I think you can adopt this. I don't think there's one solution that fits everyone. Yeah, definitely. Yeah, absolutely. I think it's what it comes down to. As a programmer, I have to sadly admit that humans are probably the most important thing in the whole system, and it really is about. Yeah. Well, LLMs are adding some. Yeah. Yeah, that culture is about. Sure. Great question. Any other questions? Sure.
You mentioned types are cheap earlier, and I think agree with that. Great point. A lot of the time when you introduce a new type to a code base, you say we've got this naming problem. We're not going to use option. We're going to come up with something new.
Yep.
You get the fresh type that you've just written. That's quite anemic in the sense that it doesn't have a lot of methods on it. You can't maybe compare it. You don't have type class instances.
Yeah.
How do you like personally balance and cope with that?
Right. Yes, I did think about this, and there are there are two answers. One is, like, in the context of this system, you're not really doing very much with those options. You're basically just pattern matching on them or folding on them, what you want to call it. And you're saying, if there's one case you do this, if the other case you do that. So it's not a huge API surface area that you need to work with. What you can do technically, if you do want a richer API for free, well, now maybe you could throw an LLM in it and it would format out the API for you. I think that's a reasonable option. You can have an opaque type, which is a subtype of some type. So in very technical detail in Scala 3, getting into the weeds a bit here, you could define your type, let's say nullable for a field that should be set to null, right? Or nullable, you can have opaque type nullable, subtype of option. Like opaque type nullable A, you can do the type parameter, subtype of option A. And then because you know that nullable is a subtype of option, it just inherits you've got all those methods available. The only problem you'll have is when you call any method from option, you won't get back a nullable, you get back an option. So you then need to do the conversion, which you can do various ways. You could have implicit conversion in Scala 3, or you can have like a little helper, which would probably be the way I'd approach it. It's just down to how much they get used. And in this situation, it's really, you're not doing much of them. You're just looking at what's the data I got in. That's the one that has a value. Everything else is equivalent to none. So it's not a case where you need a richer API. You do need a richer API. Those are the two solutions, I think. Definitely, a valid problem. Let's refine this situation, but it's something we need to think about.
Well, in Scala, yeah, we kind of tend to use types a lot, and when there are problems like this, like types are kind of a solution. Yep. And if types didn't solve it, like kind of turn up the dials a bit more on types. In like when you're talking to people who don't use Scala and maybe use languages that don't emphasize strong typing, like say Clojure or JavaScript or Ruby, do you just tell them you should switch to a better language, or?
Well, maybe it's why I'm at the Scala meetup, not the Python meetup. Yeah, it's a good question. And I think one of the things that's really interesting about this is like the way that you might see our different language communities as somewhat incommensurate. I can throw in a kind of offensive word. Like we generally just have different mental models and different attitudes to programming. And there is a understanding barrier. I'm not saying that we have a better understanding. We have a different understanding. And I definitely get that. I look at the code and it's just like, well, I wouldn't implement it that way, And I read these write-ups occasionally of people using Python or whatever it may be, and talk about how they solve problems. And like the old joke, if you want to get to wherever, I wouldn't start from here. And that's kind of how I feel. Like I wouldn't start from where you're going. I wouldn't necessarily want to go to the destination you're arriving at either. I just have a very different model. So how do you address that? That's my way I've addressed it has been by choosing the community which I work within, working these types language framework. But otherwise, I see in general there's a move towards types, right? Like TypeScript is the natural experiment showing that types are preferred for whatever reason to untyped language. You could ensure the whole could have just stuck with JavaScript, but it hasn't. It's shifted to TypeScript. I think that's becoming much more accepted now. And I think generally, say, chaos is always a time of opportunity as well. So it's when you get bugs, you go, well, we can fix that with types. Every bug can be fixed with types. If you express anything you want in the type system that has sufficient complexity, and Scala is Turing complete, like most expressive type systems are. So you can express anything if you have enough time. So it's not, in some ways, it's not actually a useful thing to say you could fix it with type, but in the actual case of the bugs that you see in practice, you could fix it with a type, or maybe you could fix it with a better use of the type system. I've showed a bunch of bugs of it, type language, but tool use is always mediated by skill. Like, not, you can't just run around with your favorite tool, no matter how fancy it is, and just treat it like a hammer and whack everything with it. You have to use it in the appropriate way.
Any other questions?
One down here, one. Okay.
They didn't have enough Python recruiters, and they had a bug in their code which would never happen in Scala. I don't remember exactly, but it was, and they used the type linter, but it couldn't figure out what was happening. And with Scala or any other normally type language, this would never happen. So it might be worth showing people, like it's easier even to get for a recruitment call if you use a type language.
One more at the back.
Didn't really need to, actually. I can project. I'm in the business of education, and I 100% agree with basically everything you said. My wonder is this something that you can teach people to do, or is it something that they have to discover by finding the same kind of horrible things that you've found?
Okay, that's a really interesting question, and it gets down to, can you teach, like, how does teaching actually work? And I think I have a particular feeling, which I think is backed up by the research, which is people need to engage with material to learn. No one learns through osmosis, which is, if there are any students in here, I think I've got one at least, sitting in your lectures just passively listening, sadly does not work. So I'm sure we all know that. Who has a stack of books by their bed they're waiting to absorb by osmosis? Right? I certainly have a stack of books. It hasn't worked so far. I keep hoping it will. So you have to engage with material to learn. But that doesn't mean that teachers are not useful. Teachers can get you where you're trying to get to a lot faster. And I believe that's backed up by research. I think not an expert in this, I think the idea that just give people stuff and let them play with it is constructivism. I think there's a general educational philosophy there. And I think there's a reasonable amount of research showing no teachers are actually better than just letting people play with things. But then, of course, there's skill in teaching and how do you present these things. And I think one of the things I try to do, and I find the hardest, is extracting the principles of what's going on behind it. So I tried to do in this talk by listing all these different ways of thinking about types. And you can kind of boil them down to the same thing in a way. Types represent what they intend to represent. Like, is ambiguity really different from the email type not representing thing? Kind of the same thing in a way. But giving people generally don't generalize very well. So calling this out as separate cases gives people, I think, a better framework to scaffold off. And I was also trying to present them, rather than going in what I typically do in a very technical way, I was trying to present them in sort of a more English writing type of, like an analogy to English writing. Does anyone here like have a background in sort of, literature, creative writing, things like that? Kind of, it'd be interesting to get what you think of like writing versus coding, because the very strong mathematical approach becomes the lens as a programmer is viewed through in the functional programming community. I have heard like English graduates say that they see writing, so poetry is one example, as very similar to coding. So it'd be kind of interesting to know what you think. So I kind of haven't answered your question, I think, but I maybe attempted to answer. I think one of the core things I think one of the core things the teacher needs to do is find the mental models to convey to the students, and then give them examples which demonstrate the application utility of the mental models. The book's all about mental models as well, if you like that kind of stuff. Metacognitive approach, if you like. So we try to think about what is the process we're using. We name that, can we be more aware of the process we're doing? Kind of what this talks about. Yeah, kind of ran the answer, but hopefully useful.
I'll try and phrase this question in a way that allows us to talk about how cool Scala is as much as possible. I'm blessed enough to work in C# and .NET usually,
Okay.
where lots of older parts of our code base are very disciplined with this, having a different type for everything an ID could represent, which as like newer code gets written, sort of like people get less disciplined about that. And I think largely at it where crashes happen and not really so proactively, because in C# that can get really quite painful and you're going through 6 or 7 layers of indirection just to get a UUID out, unless people are very, very disciplined sort of all along that layer. Could you talk about some of the awesome stuff Scala does, which makes it easier to sort of stick with that discipline and like help keep teams on track with following these kinds of very descriptive approaches?
Right. So I think one aspect needs to be cultural, which is maybe not talking about how awesome Scala is. There is sort of a cultural component of different programming languages. Languages do have cultures associated with them, what we think is idiomatic. And also, it's a different pool of developers you draw from and so on. And there's one of the advantages of having a more niche language is you have a more select pool of people who want to work with it, are generally a bit more enthusiastic about using that particular language. In terms of having lots of types and working with them, it is true I've worked on systems where you have all these different types, and the question is always like, well, the 2 questions that come up, like, what is the actual representation I'm working with? That's sometimes important. Like, how do I save this thing to a database or so on? So this is the opposite of what I was saying in a lot of the talk, where we're talking about meaning, but you do need to talk about representation at a certain point. And that can be difficult. That's actually a problem I come across all the time in languages like Python, where they don't describe exactly what they are looking for. What can I pass this function? They don't tell me. Where representation comes in. So how do you cut through to get to representation? And then how do you create instances again, which is kind of another representation issue. You can end up, I have one of these and I want one of these. How do I get from here to there? Plotting that pathway can be difficult. The tools that I think are most useful in Scala are quick go-to definition can tell you a lot. The methods associated with something, you can jump around following the types. That's one quick way of doing it. I suppose this is kind of the question you might throw at an LLM as well. They can read reams of code quite quickly. And the other thing, from a language point of view, in Scala, well, there are two ways you would do it. One is just convention that you'd have constructed on companion objects. So you go back to the nullable, the option, which is like a nullable thing we talked about earlier. We might have an extension method on option to nullable, which would be like a convention we have of just typing to and then whatever to seek, to list and so on. Or we would have a constructor on the nullable companion object, which would take an option. That would be the first place I would look. Or the other thing is we could use the implicit conversion stuff in Scala 3, which I personally haven't played with and a little bit leery of because I don't like things converting without me expecting that. I think in Scala 3 it's a little bit more constrained. You have to call a method now, right? On your head or something? So you have to have the instance available. So right. Okay. Okay. So, well, in Scala 3, it sounds like we may have a uniform way of doing this, which would make these type conversions both visible in the source code and controlled. So that might be a solution there. Is that a reasonable answer?